Pause the video now, guys, and try question number 2 from the Edexcel Pearson, okay, Pure Mathematics, Paper 1, Full A-Level. Looking at the factor theorem, okay, can you get 7 out of 7 on question 2? Okay, look at the factor theorem actually. Okay, so this is question number 2, guys. Guys, before I start, guys, yeah, it is not going to be like a little rant here. Please, please do not neglect AS Pure Maths content, okay? The full A-level is testing everything that you've learned from September in year 12. So from September 2022 up until now, okay? Please, please do not neglect the AS Pure Maths, okay? Because that's just as important as the full A-level. Of course, focus your energy more on the A2 content, but please, please do not neglect, okay, AS Pure Maths, especially when some of you, I don't want to sound arrogant, but some of you is just like a revision from GCSE Maths, okay? But yeah, that's just a little point that she mentioned, okay? But yeah, sorry for actually ranting. Okay, question number 2. F of x equals 2x cubed plus 5x squared plus 2x plus 15. Part A, use the factor theorem to show that x plus 3 is a factor of f of x. So the factor theorem states, guys, that f of a is equal to 0 if and only if x minus a is a factor, okay? That's the key to remember, okay? Or f of minus a is a factor, sorry, f of minus a equals 0 if x plus a is a factor, okay? That also works, okay? But I'm just used to doing it as x minus a in my videos, okay? So we're going to substitute in minus 3 into the function, okay? So we're going to have f of minus 3, guys. F of minus 3 is equal to, okay, 2 times minus 3 cubed, okay, plus 5 times minus 3 squared. Okay, again, I'm putting it in brackets, so when you enter it in your calculator, it's very clear, okay, about my line of working, okay? Please, please, please also, please show your full workings in the exam, okay? I cannot stress that enough, okay? That can be the difference between a C and a B, a D and a C, a B and an A, and an A and an A star, okay? That is honestly, like, I'm not actually exaggerating that, okay? So by showing your full workings, okay, you're giving the examiner any opportunity to offer you marks, okay, even if you make a mistake, okay? So minus 3 cubed is going to be minus 27. That'll be minus 54. So we got minus 54 plus 5 times minus 3 squared. So that'll be 9. That'll be plus 45. Okay. Minus 6 plus 15. Okay, we can see here that minus 54 minus 6 is minus 60. Minus 60 plus 60, because 45 plus 15 is 60, that equals 0. Therefore, x minus 3 is a factor. Sorry, x plus 3 is a factor. Okay, so x plus 3 is a factor because f of minus 3 is equal to 0. Okay, now also, yeah, point to mention here, they might not always give you like the factor here in the exam. If they ask you to obviously find a root here or a factor, okay, you always start by finding the factors of the n number, okay, and you test the positive and negative cases of the factors of the n. Sorry, so yeah, therefore x plus 3 is a factor, okay, of f of x, okay. But yeah, sorry, what was I saying actually? Yeah, so if they ask you to find a possible factor to the cubic expression, okay, or the cubic equation or the cubic polynomial, okay, you work out the factors of the n numbers. So you pick the positive and negatives, okay, start with 0, then try 1, try 2, try 3, so on and so forth. Yeah, sorry if I'm actually waffling a lot today, guys. Part B, find the constants a, b, and c such that f of x is equal to x plus 3 multiplied by this general quadratic ax squared plus bx plus c. I'm going to use polynomial division. Okay, so I'm going to do 2x cubed plus 5x squared plus 2x plus 15. Okay, dividing by a linear factor. Okay, there is like another method here to obviously dividing by an algebraic linear term, and that's by inspection. Okay, so if you're interested, okay, I think TL Maths has got a lot of videos on like the inspection method where you just like inspect it and you compare the coefficients, but I much prefer polynomial division, okay, because it's much easier for me. That's going to be 2x squared there, okay, 2x squared times x will be 2x cubed, 2x squared times 3 will be 6x squared. Okay, subtract that. Okay, I think I actually prefer this method here because obviously I'm so used to it, like from either primary school or GCSE when doing like short division. Okay, 5 minus 6 here will be minus 1x squared or minus 6 squared. Then you got the plus 2x, okay, plus 15. Yeah, sorry guys for like waffling a lot actually in today's video. Actually, I think it's going to go on a bit longer than I expected, so I apologize for that. Minus x times this will be minus 1x squared, okay, minus 3x, okay. I can't actually delete that actually, unfortunately. So 2x minus 3x will be 5x. You got 5x plus 15, and then I'm going to put 5 on the top, okay. And then hopefully you can see that 5 lots of x plus 3 will give me 5x plus 15, which will just cancel out, okay, and I get a remainder of 0, okay, for that, okay. So therefore f of x is equal to x plus 3, okay, lots of, okay, or brackets, okay, 2x squared minus x plus 5. And hopefully you can see at this stage that that quadratic will not factorize, okay. Obviously, yeah, it is not obviously very obvious, but because of this, like, like the coefficient of x obviously being bigger than 1 being positive, and the coefficient of x being like a small negative, okay, and then obviously the constant c at the end, okay. So let's just delete this. We got a bit more space. Okay, so that is my quadratic. Hence show that f of x equals 0 has only one real root. So we're going to show that the discriminant of this is less than 0. So a equals 2, b equals minus 1, and c equals positive 5. Okay, the discriminant is the bit inside the square root for the quadratic formula. Okay, if it's less than 0, then it means it has no real roots, and therefore it does not cross or intercept the x-axis. So we're going to have b squared minus 4ac. Okay, b squared will be minus 1 squared, so that'll be 1. So 1 minus 4 times 2 times 5. Okay, 4 times 2 is 8. 8 times 5 will be 40. So we got 1 minus 40, which is 39. Okay, sorry, which is minus 39, which is less than 0. Okay, therefore, the quadratic has no real distinct solution, we say, from GCSE Maths. Okay, so the graph, if you're interested for the quadratic, will look something like that. Okay, crossing the y-axis at 5. Part D, write down the real root of the equation fx minus 5 equals 0. Okay, so that means that my graph has been shifted, okay, 5 units to the right. Now, if the root is -3 and I shift that, okay, to the right by 5, it'll be -3 plus 5, which would be +2. So my quadratic, okay, for fx minus 5 would just read, okay, x minus 2 and then multiply by that quadratic, okay, because the quadratic would still stay the same, okay, because I'm actually just shifting everything 5 places to the right, okay. So we can see that f of x minus 5, f brackets x minus 5 will only have a solution at x equals 2, okay? Because the quadratic would not have been affected by the transformation, okay? It's moved 5 places to the right, okay, that cubic graph, okay? So it crosses the x-axis at one point, which is +2, okay? The quadratic would still remain, okay, unsolvable, okay, i.e. the discriminant would still be less than 1, okay. But that's it from me today, guys. Yeah, sorry if actually waffling a lot today, but I hope you found this video useful, okay. Please do not neglect this here. This is a question which I'm almost certain will come up here on either your paper 1 exam on Tuesday or your paper 2 exam the following Tuesday or the following Wednesday, okay. So please do not neglect the AS Pure Maths material, okay, especially the factor theorem, yeah, and the remainder theorem. Okay, revise that topic. Okay, bye for now. Take care. All the best.